All right, so we've been talking about exponential functions, right? The first way we focused on it was dealing with looking at geometric sequences and seeing that those are special cases of exponential functions. Went into a little more detail about what an exponential function was, and it's really something of this form: some function where it's a, which is the initial amount, b, which is the constant rate of change, if you will, and then raised to the variable as the exponent, right? So this is the general format of the exponential function. I want to take that a little further with a specific example of exponential functions called exponential growth and decay. I'm going to start off by looking at just the basic function of all exponentials, right? It's the same thing there, ab to the x, ab to the x. A is the initial amount, b is that constant, I'm going to say growth or decay. When we were dealing with geometric sequences, we called that thing the common ratio. But the common growth or decay will tell us, this number will tell us what we're going to do, if we're going up or if we're going down. And then x is just a variable. All right, so with that said, if you were to graph these, and we had some other practice on graphing, if you were to graph something and it did like this, something like this, as opposed to something, let me make my page a little bit bigger, that did something like this. All right. Sorry about that. Well, if you go from left to right here, you get a growth, you go up. If you go from left to right here, you go down. We don't, in this case, say go down. We're going to call it a decay. Okay. So if I were to look at the function that looks like this, the function of this type of growth will have an initial amount, and then it will go up some. So we'll have the b to the x, where the b will be greater than 1. This one will have the same format, of course, because that's what all exponentials look like, but the b will be less than 1. All right. So this goes there. So the way that you can tell if something is an exponential growth or an exponential decay situation is by looking at the b. If I gave you an example of this, I would say something like f of x is equal to 2 times 3 to the x. That is a growth because b is greater than 1. Here, my example would be f of x is equal to 2 times 1/2 to the x. All right, and we can do some examples of how we go about that, and we'll do that here. But I just wanted to show you the difference between growth and decay. So any kind of situation that shows that will be a situation that talks about exponential growth or exponential decay. If you are increasing with a number greater than b, then your number will keep getting bigger. If you keep increasing by a number less than 1, like down here, your numbers are going to get smaller. When you do 1/2, for example, 1/2 to the first, 1/2 to the second, and just for comparison's sake, 1/2 to the third. So I'm making my x's get bigger even though my base is 1/2. I get 1/2. This is 1/4. This is 1/8. This is all going down. So we're getting smaller. So if this b is less than 1, your graph starts to get closer and closer to 0, but it won't ever touch it. All right, so that's an overview of exponential growth and decay, just a general overview. We're going to apply that here with a couple of examples.